So in this video today, we're going to find angles using inverses of trigonometric ratios. So we're going to use them to find the missing angles in a right triangle when we have the sides, okay? So if you know the sine, cosine, or tangent of an acute angle measure, then you can use the inverse trigonometric functions to find the measure of the angle. So that means if we do the inverse, if we do the sine of x, it equals x, right? So that's going to be a ratio. But if we're trying to find the actual angle, then what we're doing are inverses, okay? So when we're trying to find angles, we do inverses. When we're trying to find sides, we just do sine of the angle, cosine of the angle, tangent of the angle, right? So if we're trying to find, again, the inverses tell us the angles, okay? So that's what we're going to be doing. So it says calculating the angle measure from trigonometric ratios. So what you're going to do on your calculators, you could go second cosine, 0.87. In Desmos, you're going to find the function that says cosine to the -1, okay? That's what you're looking for. Go ahead and do these three on your calculators and then come back to me when you're done. So it says we're going to round each to the nearest degree. Well, when I put this in the calculator, it was 29.5, but if I round that to the nearest degree, that's 30 degrees, isn't it? Okay, here again, if I take the inverse sine of 0.85 in the calculator, that's 58.2, which we know rounds to 58 degrees. The inverse tangent of 0.71 was 35.4, but again, that rounds to what? 35 degrees. Remember, if it's a 4 or below, we leave the number what it is. If it's a 5 or above, we round it up, okay? So go ahead and do these you-dos and come back to me when you're done. So here again, this was 37 degrees, this one was 87 degrees, and this one was 42 degrees, okay? All right, so using given measures to find unknown angle measures or side lengths of a triangle is also known as solving a triangle. So to solve the right triangle, you need to know the two side lengths or one side length and an acute angle measure. So you need at least two parts, y'all got me, to find an angle, right? And we can find the third as well. So it says solving the right triangle when given two sides. So find ST, so we're actually finding this, right? Then it says find the measure of angle R and the angle T, okay? So it says round the lengths to the nearest hundredth and the angle measures to the nearest tenth. So can't we use Pythagorean's theorem, y'all, to find ST? We can, right? So because again, what is this? This is our hypotenuse, right? So we're going to use a squared plus b squared equals c squared. So that's going to be ST squared plus 5 squared, and that's going to be equal to 5.7 squared, right? So when we do that, we get 25, or ST squared plus 25, and this equals 32.49, okay? Then we're going to subtract the 25 from both sides, right? Subtract the 25 from both sides. So we got ST squared equals, I got 7.49. Now, remember, we don't want ST squared, we want ST, so we got to take the square root of both sides, right? So take the square root of both sides, so ST is going to be equal to 2.74. So I'm going to go ahead and put it over here, 2.74. Now listen, I don't use things I found, because what if I made an error, to find something else? So I'm going to use what I have, okay? So now, we could also use the trig ratio here, right, to find that angle. But first we got to find the angles, okay? So step 2 is finding the angles, okay? That's what we're going to do. So we're going to do inverses. So once again, we're going to look at, so let's look at angle R. So we're going to find the measure of angle R. So what do we have? We have the hypotenuse, right? And what is this right here? It's beside it, right? So if it's beside it, this is adjacent, right? So what ratio uses adjacent and hypotenuse? So that's adjacent and hypotenuse, right? So isn't that going to be cosine? So we're going to say the cosine, the inverse cosine, right, of our adjacent, which is our 5, over our hypotenuse, which is our 5.7. Go ahead and put that into our calculator, and we're going to get 28.7 degrees, okay? Now, we could subtract that from 90 to get angle T, right? So this was the measure of angle R. So to find the measure of angle T, we could go 90 minus the 28.7, and that would give us 61.3 degrees. Or we could use another ratio, right? So now let's look at angle T. So how does this relate? It's opposite now, right? So that would be the sine, the inverse sine of 5 over 5.7 is our hypotenuse again, right? So that's sine. So again, if we do that in our calculator, we get 61.3 degrees. So there's two ways to find that third angle, okay? Subtract the second angle from 90 or use the trig ratio again. All right, now, so what we do here, we're going to find GH. Y'all need to find change that, whatever it said. I think it said FH to GH, right? Because we already have FH, okay? So once again, we could use Pythagorean's theorem, right? So this is our H. We're going to go ahead and label it, right? So can we go 3.5 squared plus GH squared equals 8 squared, right? So 3.5 squared is 12.25 plus our GH squared, and that's going to be equal to 64. We're going to subtract the 12.25 from both sides, right? So GH squared is going to be equal to 51.75. Now what do? We take the square root, right? We're going to take the square root of both sides because we don't want GH squared, we want GH. So GH is going to be equal to 7.19. Done with that, okay? Now we need to find the angle. Now listen, I don't use what I find to find the angle. I use what I have, what was given in the problem, because if I make an error here, then I'm going to repeat that error when I'm trying to find the angles, okay? So what I'm going to talk about angle F, right? So I'm going to do measure of angle F, okay? To do that, so let's compare these sides. So we have our hypotenuse, right? And isn't this our adjacent? So what ratio uses adjacent and hypotenuse? Cosine, right? So we're going to do the inverse cosine of 3.5 divided by our 8. That's what we're putting in our calculator. 3.5 divided by 8, and when I did that, I got 64.1 degrees. It says round to the nearest tenth, okay, for the angles. Okay, now I'm going to actually use another ratio to find, okay, so that was measure of angle F is equal to 64.1 degrees, okay? Now I'm going to find the measure of angle H. The measure of angle H, this time, this now becomes opposite, doesn't it? Isn't this now our opposite right here in hypotenuse? So this is going to be sine, right? So that's going to be equal to the inverse sine of the same values, 3.5 over 8, right? So when I do that, put in the calculator, it equals 25.9 degrees. Now, I could have just taken that first angle, 64.1, and I could have done just 90 minus 64.1, but I kind of like double checking myself, so that's why I did it the other way, okay? So 25.9 degrees is what it would have been. Okay, let's see if you guys can do the try. Come back to me when you're done. So again, FH, this is going to be my hypotenuse, right, which is equal to my C, yes? So we would do 8.2 squared plus 4 squared. That equals FH squared, right? So when I added these two together and combined them, I got 83.24 equals FH squared, right? What do? Take the square root of both sides, right? Square root, square root. So FH is going to be equal to 9.12, and it would be miles. But, okay, now let's talk about what are we going to do. So if we're looking for angle F, the measure of angle F, this is opposite and this is adjacent, right? Okay, so the measure of angle F is going to be opposite and adjacent is what? The inverse tangent of 4 over 8.2. So the measure of angle F, go ahead and do that in your calculator, was 26 degrees, right? Okay. Now remember, we can do the inverse tangent of 8.2 over 4 to find the measure of angle H, or we can do 90 minus the 26, and that's going to be equal to 64 degrees, right? Okay. Then example 3 says solving right triangles given one angle on one side. Okay, so here again, we have one angle this time on one side. So what is this angle right here? How would we find angle D? Wouldn't we just do 90 minus 58? 90 minus 58, trying to find my notes here, y'all, is 32 degrees, right? 32 degrees is equal to the measure of angle D, okay? Now, we need to find EF and DF, right? So if we're looking for EF right here, okay, how does that relate to the 58 degrees? Remember, we're going to use the angle measure we have, right? So isn't that adjacent? So this would be adjacent, and wouldn't this be opposite? What ratio uses opposite and adjacent? Tangent, right? So we're going to say the tangent of 58 is equal to the 14 over EF. Now remember what we said. What happens when we do this? These swap places, right? So that means EF is going to be equal to 14 divided by the tan of 58. Go ahead and do that right there in your calculator and tell me what EF is. That was 8.75. Now you could use Pythagorean's theorem here, or you could use the ratio for the other one too. So if we're looking for ED, how does ED relate to the 58 degrees? Now what? So this time, not ED, sorry, we didn't want ED, we want DF, right? DF, sorry, my bad. DF is equal to, so this is now our hypotenuse, right? So we got our hypotenuse and we got our opposite. What ratio is that? That's sine, right? So we're going to say what? DF, we're looking for DF now, right? So DF, okay, that's what we're looking for. So wait. We're going to do sine of our 58, right? That's going to be equal to opposite, which is 14 over DF. Once again, what happens here? Yep. These things swap, right? So we're going to have DEF equals 14 divided by the sine of 58. And when we do that, we get 16.51. Okay? All right, this next one, let's see if we can do it. You guys pause the video here, see if you can do it. Well, the measure of angle A is equal to 90 minus 62, right? 90 minus 62 is 28 degrees, right? So we got that angle done, okay? Then we're trying to find BC and AB, okay? So if we're trying to find BC, we're looking for this, right? How does it relate to the 62 degrees? It is what? Adjacent, right? And this is opposite. What ratio is that? Look on your formula sheet, tangent, right? So it's going to be the tangent of 62 equals opposite 25 over our adjacent, which is our BC, right? Now what happens here again? They're going to swap places again, aren't they? Swapping, yep. So BC equals 25 divided by the tangent of 62, and that equals 13.29. Okay, now let's find AB. So we're looking for AB. So, okay, now we're looking for this, right? So how does that relate to that angle? This is the hypotenuse, isn't it, y'all? So we have the hypotenuse and we have the opposite still. So what ratio uses opposite and hypotenuse? Sine, right? So we're doing the sine of 62 equals what? 25 over our AB, right? Once again, they swap places. So this is AB equals 25 divided by the sine of 62. Do that in your calculator. When you do that, you get 28.31 for our side. Okay? All right, let's see if you guys can do this. You do. Come back to me when you're done. Finding angle B. Measure of angle B is equal to 90 minus 53. Pretty sure that is 37 degrees, isn't it? Where's it at? Yep, 37. Okay. Okay, gonna find, what do we want to find first? AB? So this is our hypotenuse, right? Okay, and what is this? Isn't this opposite? So isn't that going to be the sine of 53 equals our opposite, which is 10, over our AB. They're swapping places again. So AB is equal to 10 divided by the sine of 53, right? So AB was equal to 12.52. AB is equal to 12.52, okay? Now, what about AC? What are we going to do to find AC? So if we're looking for this right here, right, isn't that going to be adjacent? It is. So opposite over adjacent. So when we're looking for AC, we're going to say opposite and adjacent is tangent, isn't it, guys? So we're going to say the tangent of 53 is equal to opposite, which is 10, over our adjacent again, which is AC, right? Again, swapping places. So AC is going to be equal to 10 divided by the tangent of 53. 10 divided by the tangent of 53 was 7.54, okay? All right, so these last few have to do with a grade in a road, okay? So it says travel application. A highway sign warns that a section of road has a 7-degree grade. To the nearest degree, what angle does the road make with a horizontal line? So this means 7% is 7 over 100, right? So we're going to make 7 our height and 100 our length, okay? And then we're going to figure out what degree that angle is, right? So isn't this going to be our opposite, and isn't this going to be our adjacent? It is, right? So we're going to do the inverse tangent, because that's opposite and adjacent, of 7 over 100. Put that in your calculator, and when you do, you get that it's a 4-degree angle, okay? Now this one's similar, right? This time it's only a 26-degree grade. Okay, every one of these you're going to use tangent with y, because we're looking for that angle right there, right? So again, this is opposite, this is adjacent, right? So it's going to be, again, the inverse tangent of 26 over 100. When you do that, what did I get? Where's my answer? I got 14.57, and it says round it to the nearest degree, so this was 15 degrees. Okay, one more. Baldwin St. in Dunedin, New Zealand is the steepest street in the world. It has a grade of 38. So that means what? 38 over 100, right? So that means this right here is going to be 38. This is going to be 100, okay? It says to the nearest degree, what is this? What is this? To the nearest degree, what angle does Baldwin Street make with a horizontal line? So we're looking for that angle right there, right, again? So we're going to do the inverse tangent of 38 divided by 100. And when I did that, I got that it was 21 degrees. And y'all would be amazed how steep 21 degrees is in a road.